Let's take a look at the distribution of the sample proportion. Type of problems we'll run across in this section is if you're trying to find a probability that more than 30% of students believe in ghosts. So you're basing it upon percents or proportions. Well, remember our sample proportion is p hat is equal to x over n, and sample proportion is a statistic that estimates the population proportion p. Now, our sampling distribution of p hat for a simple random sample of size n with a population proportion p, the shape of the sampling distribution of p hat is approximately normal provided n times p times 1 minus p is greater than or equal to 10. The mean of the sampling distribution of p hat is mu sub p hat is equal to p, and the standard deviation of the sampling distribution of p hat is sigma sub p hat is equal to square root of p times 1 minus p divided by n. Now n is less than or equal to 5% of capital N, 5% of the population. Little n is your sample size and capital N is your population size. Now to do this by hand for these probabilities, we'll find the mean and standard deviation, and again these are what we had in the previous slide. Mu sub p hat is p and sigma sub p hat is square root of p times 1 minus p all over n. Step 2 is convert the values you're working with to a z-score. Round your z-score to 2 decimal places. And step 3, look it up in a table based on area to the right, left, and in between. Now if we're using the calculator, TI3, TI4, first 2 steps are the same, and then we plug it in one of the following 3 forms. Now the first one is normal CDF, and then Z, comma, E99, comma, 0, comma, 1. The first one is when it's shaded to the right. The second one is normal CDF, negative E99, comma, Z, comma, 0, comma, 1. This is when it's shaded to the left. And then the third one is normal CDF, Z1, comma, Z2, comma, 0, comma, 1. This is when it's shaded in between 2 values. Well, let's look at our problems. It says according to www.statisticbrain.com, 70% of YouTube visitors from outside of the United States. Suppose a random sample of 800 YouTube visitors are asked where they are from. Describe the sampling distribution of p hat. Be sure to verify the model. Well, p is going to equal to 0.70, 70%, or 0.7. Now, we want to verify that n times p times 1 minus p is greater than or equal to 10. So we got 800 times 0.70 times 1 minus 0.70. And let's see what that's equal to. So I got 800 times 0.70 times, beginning parentheses, 1 minus 0.70. You could also put 30% in there. And we get 168. So that fits the criteria of that. Now also, 800 YouTube visitors, so that sample size is definitely less than 5% of the population. Because there's tons of YouTube visitors out there. It's approximately normal. Not that I can spell approximately. Good thing I teach math. So approximately normal with the following. Sigma sub p hat, this is given over here, is equal to p, which is 0.70. Sigma sub p hat is equal to the square root of p times 1 minus p over n. So we got square root of 0.70 times 1 minus 0.70 divided by n, which is 800. Let's see what that is. Second x squared for the square root. 0.70 times 0.30. If the first one's 70%, they have to add up to 100%, so this is 0.30. Divide by 800. Enter. And it'd be 0.016201 8517. And that's the first part of our problem. The second part, let me actually put that on a separate page. I want to have room. That's part A. Describe the sampling distribution, verifying a model. So let me save that. ES distribution of sample. What is this? Sample proportion. Page 01.pdf. Okay. Part B. Now, some of this is still holds true, so I should write it down again, I guess. So n is 800, and p is equal to 0.70. Okay, in the sample obtained in Part A, what is the probability that the proportion of visitors who are from outside of the United States is greater than 0.74? Okay, so we got 0.74, greater than is shaded this way. So that's the picture they're asking. They're asking for probability. Let's first do it using the calculator. Step 1 says find your mu sub p hat and sigma sub p hat. Well, mu sub p hat is equal to p, which is 0.70. And sigma sub p hat is equal to square root of p times 1 minus p, and divide by n, which will be 0.70 times 1 minus 0.70 divided by n, which was 800. I already got that in there, don't I? 0.016201 8517. Now I'm going to store that off because I'm going to use that over and over. So I'm going to press my store button, and I'll put it into, what do I put it into? It's sigma, so I guess I'll put it into S. So I do alpha ln to get the S and press enter. Okay. Now I'll probably write that down on every problem just because I want to show the full steps. Sometimes students have a hard time working these problems. Okay, step 2. Convert the value you're working with to a z-score. Round the z-score to 2 decimal places. So we got z is equal to p hat minus mu sub p hat divided by sigma sub p hat. Well, the p hat that it's referring to is this right here. So whatever value you have down there is going to be your p hat. So we got z is equal to p hat, which is 0.74, minus mu sub p hat, which is 0.70, divided by sigma sub p hat, which is 0.016201 8517. And so that'll be 0.04 divided by something. But again, if I'm plug that in my calculator, I'll put beginning parentheses 0.74 minus 0.70 divided in close parentheses divided by. If you have more than a single number on top or bottom, put parentheses around it. And I stored that off in S, so I'm going to do alpha ln to get the S back. Or you could type in the 0.0162018517 again. And I'll round this to 2 decimal places, so we got 2.47. Okay, that was step 2. Convert it to a z-score. So now our picture, remember our picture up here was greater than, so shading to the right. So this is now z is equal to 2.47 shaded to the right. And step 3. I'm shading to the right, so it's going to E99, so it's the first one. So we'll do normal CDF, 2.47, E99, and then 0, and then 1. And I'll do second vars, choose normal CDF, 2.47, excuse me, comma, second comma for the E99, comma 0, comma 1. Little trick on that is if your mean and standard deviation are 0 and 1, you don't even have to put them on. So our answer will be 0.0068, rounding to 4 decimal places. Now I'm going to jot that down on a piece of paper, because I'm going to start a new page here, and I want to compare that probability to the next one. So that's using the calculator. Okay. There we go. Now let's look at 1B again, using the by hand. Now still, let's see, N is 800, and P is 0.70. And it says from outside is greater than 0.74. So here's 0.74, and this is again p hat. They're telling us p hat is 0.74, and we're saying greater than that. So that's what a picture looks like. So if we come up here, we'll find the mean and standard deviation just like before. So we got mu sub p hat is equal to p, which is 0.70. Sigma sub p hat is equal to square root of p times 1 minus p divided by n. So we have 0.70 times 1 minus 0.70 divided by 800 equals. And we already have this in our calculator. If I do alpha ln for the S and press enter, that was this value. So this is 0.0162018517. Now again, I have that stored in S, so I can access it later. Step 2, convert it to z-score. So we've got z is equal to p hat minus mu sub p hat over sigma sub p hat. Okay. P hat was, what was it? 0.74. So this would be 0.74 minus mu sub p hat, which is 0.70, divided by sigma sub p hat, which was 0.0162018517. So I got 0.74 minus, what am I doing? Beginning parentheses, 0.74 minus 0.70, close parentheses, divide by S. So I do alpha ln to get the S. And we get 2.47. Now that's no big surprise. That's what we got before, wasn't it? Now this is the only problem where I'll do all these steps out here because the first two steps are the same. So I'm going to kind of work them together, save some time. Now our picture. Remember, our picture is we're shading to the right, like this. Well, that's no good for the tables in the back of the book, so we have to do 1 minus, and then z is equal to 2.47, the area to the left. Again, 1 is everything, so if I subtract off the area to the left, that'll leave us the area to the right. So let's go look up 2.47. Well, the 7 is in the hundredths place. I'm looking in this 0.07 column. 2.47 is 0.9932. And let's see what that gives us. 1 minus 0.9932, enter. 0.0068. This is what we got. That's exactly what we got using the calculator. So we save that. And let's look at part C. Right there. Okay. Let me go back to the first one here. Okay, let me write down this. N is 800. P is 0.70. Okay, in a sample obtained in Part A, what is the probability of the proportion of visitors who are from outside the United States is less than 0.65? So that's our picture. And when they give us less than 0.65, that's p hat. So that's what they're asking. Okay. Now let's come back here, and we'll do it on the calculator first. Though actually the first two steps are the same for both of them. Our first step, mu sub p hat is equal to p, which is 0.70. And sigma sub p hat is equal to the square root of p times 1 minus p over n, which is 0.70 times 1 minus 0.70 divided by 800 gives us see alpha ln enter this right here. And I already got that stored off again, so I'm going to keep using that. 620.185.17. And second step is convert the p hat equals 0.65 to a z-score. So we've got z is equal to p hat minus mu sub p hat over sigma sub p hat. P hat in this one is 0.65 minus mu sub p hat, which is 0.70, divided by sigma sub p hat, which is the 0.016201.8517. Again, we'll put parentheses around top when you plug it in the calculator, or you can do that in your head. So 0.65 minus 0.70, closing parentheses, divided by, and I stored that in S, so I'm going to do alpha ln to get that, and press enter. And I'll take it to 2 decimal places, so we get negative 3.09. I wonder if that's even going to be on our table. Now our picture now looks like this. We got z is equal to negative 3.09, shaded to the left. Okay. So step 3. First, let's look at it with the calculator. It's going to shade to the left, so we're going to negative E99. So we'll do normal CDF, negative E99, and then our negative 3.09, and then 0 and 1 for our mean and standard deviation. So I got second vars, normal CDF, negative E99, comma, negative 3.09, comma, 0, comma, 1. Enter. That's pretty small. 0.0010. Okay. Now let's look at it by hand. We're going to look it up in our table. Since this is z-scores and it's the area to the left, then all we have to do is look up the negative 3.09. Well, the 9 here is in the hundreds place, so that means we're going to look in the far right column. So we're going to look for negative 3.0. Negative 3.0 is right here. I go clear to the right, and I get 0.0010. So that'd be your answers via calculator and by hand. So again, the first two steps are the same on these particular problems. So let me save that, and we'll look at part D. Now I know the step 1 and step 2 are the same on all of these, and you're saying, why does he keep doing that? I want to show you the entire steps. So you look at part C, you see the entire flow. And if nothing else, this makes an exciting video, so it can help you sleep at night. You can just turn it on and you immediately go to sleep. Let's look at D. No memory. I don't remember what N is. N is 800. And P is equal to 0.70. And D says, in a sample obtained in part A, what is the probability of the proportion of visitors who are from outside the States is between 0.60 and 0.68. Okay. So they're telling us P hat is equal to 0.60, and P hat here is equal to 0.68. There are two different P hats, in case you're wondering, but that's what they're asking. Okay, so step 1. Oh yeah, find mu sub P hat. So mu sub P hat is equal to P, which again is the 0.70. Sigma sub P hat is equal to square root of P times 1 minus P over N, which is 0.70 times 1 minus 0.70 divided by 800, which again, I almost got it memorized. Well, no, I don't. I'm lying. Let me do alpha ln and get that. So that's 0.016201 8517. And second step is change these to z-scores. Well, we're going to have two of them. This is like the first one, and this is like our second one. So for our first P hat, we're going to have 0.60, and our second one we'll have 0.68. And you're going to find the z-score corresponding to both of these. So it's P hat minus mu sub P hat over sigma sub P hat. And this one the same way. I'm about ready to go to bed. I'm tired. Okay. So for this one, P hat is 0.60 minus mu sub P hat, which is 0.70, divided by sigma sub P hat, which is the 0.016201 8517. And this one is 0.68 minus 0.70 divided by that. And I'll label this as 1 and label this one as 2. Just to indicate they're different. So this one we'll have beginning parentheses 0.60 minus 0.70, closing parentheses divided by, and I put that in S, so alpha ln, enter, and then we get negative 6, that's big, 6.17. Okay, let's find our other one. So beginning parentheses 0.68 minus 0.70, closing parentheses divide by S, so alpha ln, enter. Then we get negative 1.23. Okay, so what we're looking at now is we got this picture. So we got Z equals negative 6.17 and Z is equal to negative 1.23, and we're shading in between. Okay, so let's go down to step 3 for the calculator. Now if it's between two values, you use the last form. So we're going to do normal CDF, negative 6.17 comma negative 1.23, so our lower value and our upper value, and then 0 and 1. So I got second vars, normal CDF, negative 6.17 comma negative 1.23 comma 0 comma 1, enter. And we get 0.1093. Now by hand, the tables are based upon the area to the left, so we're going to have to rewrite this as Z is equal to negative 1.23, the area to the left of that, minus, and then area to the left of negative 6.17. That's the between case. You always write it that way. The value on the right side goes here, and then one on the left goes here. Let's go look this up in our table. Negative 1.23, the 3 is the hundredths place, so it's right here. And negative 1.23 would be this, which would be 0.1093. Minus, and there's no negative 6 in this, so my smallest value is clear over here, negative 3.49, which would be 0.0002. If I subtract those, I think I get 0.1091, like that. And where's the calculator? Oh, 0.1093. So it's not exact there, because I couldn't do an exact value because that isn't even on our table. So again, your calculator will always be a little bit more precise than the other. And let me save that. And then we got the last part to look at. E. N is still something, 800. P is 0.70. Now E says, would it be unusual that in a survey of 800 YouTube visitors that 400 fewer from outside the United States? Okay. What they're telling us here is they're telling us X equals 400 or fewer. So shading that way. Now when it says would it be unusual, we want to see if what the probability is. See if it's less than 5%. Or if it's greater than 5%. Well, they're not giving us p hat here, they're giving us x. But remember, p hat is equal to x over n, and x is 400 over n, which is 800. So p hat is equal to 0.50. So what they're really saying is this picture you see right there is going to change to what we have been working. They're saying x is less than 400. This will be p hat is less than 0.50. And let's go through our steps. Okay, so sigma sub p hat is equal to p, which is 0.70. Sigma sub p hat, I won't go over it again. I think you've seen it enough that you're probably ready to snap. Let me do alpha ln. It's this value. Look at ports B, C, and D if you have forgotten how to do it. 016, 201, 8517. Now 2, we want to change this to a z-score. So we got z is equal to p hat minus mu sub p hat over sigma sub p hat. Our p hat is 0.50 minus mu sub p hat, which is 0.70, divided by 0.016, 2018, 517. So let's see what that gives us. Do a beginning parentheses, 0.50 minus 0.70, closing parentheses divided by s. So I'll do alpha ln, and then enter. Wow. Negative 12.34. So our picture now is z equals negative 12.34, shaded that way. So for step 3, via our calculator, we'll do normal CDF. It's going to the left, so it's negative E99, and then negative 12.34, 0, and 1. So I do second vars, normal CDF, negative E99, comma, negative 12 point something, 34, comma 0, comma 1. Enter. 0. So would it be unusual? Yes. Okay, by hand. If I look this up in a table, negative 12, and it's going to be different by a table. So as weird as that seems, our smallest value is a negative 3.49, which would tell us that right there. So either way, it's unusual. So, let me save that. Go. Oops. Where'd I go to? And let me stop the recorders.